So I'm here today with my Arkessa hat on. Arkessa is a leader in the mobile network space for end-to-end. But I've got another hat with my own startup called DriveUp, which is a IoT-orientated startup around telematics on smartphones. So I've got a little bit of experience myself in achieving seed funding for the European Space Agency, so I'll be happy to answer any questions around that after. When I was preparing today's presentation, I didn't quite appreciate that there might be quite a few audience members who didn't actually know what the 80s were. The 80s were when some of us had awkward haircuts and were listening to little things called Warwick, which you may or may not have heard of. So, end-to-end, coming out of the 80s to where we are today, the Internet of Things. The key enablers around the infrastructure space, the hardware. The hardware is largely here. There's devices, there's networks, there's equipment. But the key point is it's cheap and it's ubiquitous. The applications and software infrastructure is largely here. Cloud, the as-a-service economy, big data, all key enablers to creating value from the Internet of Things. The data, from our point of view, and the connectivity are the two areas where Arkessa has a significant amount of experience. So what we're going to do with these components? Well, we're going to look at the market. The market is saying, and it has been saying for some time now, that the Internet of Things, end-to-end, its time has come. But today, again, time has come, demand's going to be huge. It's time to make that investment. And it will be disruptive. We're all expecting the 10,000 devices around the home to have a significant impact on our lives. What we don't know is what the impact is going to look like. The killer app for the Internet of Things, I'd like to know what it is. I'd like somebody to tell me, perhaps later on we can have some ideas. But it will be big. So how does it look like? What does it look like dragging end-to-end and the 80s into the Internet of Things that we have today? So an example, there's a house there, it's a Dutch house, I don't know why, it's just Dutch. In that house, in the 80s, my parents invested in a few home taps. An alarm system, a KIS, connected to red detectors around the home. Now they're aging a little bit, they need another system to look after them, a telecare system that monitors their health and well-being to a call centre. That's got two sets of sensors in the home. Two sets in every room. But the data from those sensors goes to completely different companies and completely different services. What we're going to do with that data is what drags us from end-to-end to the Internet of Things. It's the use and reuse of those sensors and the data from those sensors. So as we can see today, two different gateways. We bring those together to a single system and to create new use cases. So back in the 80s, we had things like this sitting around the home. Still one of those in the loft somewhere. Bespoke systems that could only be used for those particular components. What we need to do is break the links between those physical components and free the data to be shared for these new use cases. Today in that house we have multiple occupants with multiple needs, but the same set of data, same set of information. A number of different applications can be created using that data and that connectivity, those sensors. So what's that going to look like if we scale it up into a community? First of all, we aggregate data from lots of different sources. It might be roadside traffic monitoring, it might be energy consumption in the home, it might be trackers in fleets. We collect that data from those sensors and we aggregate it. We then need to analyse that data. take action from it. Again, largely siloed. We can start to bring that in if we use some of these new components that we have around big data to deal with the velocity, the volume, and the variety of data that's coming in. Again, to create a whole new set of actions and outcomes. We take the data from the sensors. I mean, many of them. Sorry, a little bit behind. We have a different impact on the community. So, for example, if we're trying to manage traffic, we're hooked into smart building systems, we can see when people start to build buildings, they turn on lights, they open doors, consumption profile changes. Next, we know there's going to be an impact on traffic in that area. We can then use that information to shape traffic measures. So, specifically, what can we do in order to enable some of these new use cases going forward? How do we get the data from those devices? So let's look at some open standards, Oracle, Java, embedded standards-based applets to collect data, shape it to a data architecture, transmit it to a central collecting point, which can then be integrated with external data sources, networking the users, and again, create a wide range of different applications and uses. Data is going to be one of the biggest issues and also one of the biggest benefits that will come from these thousands of devices that will be created by the Internet of Things. This is about some of the architectural components, the infrastructure components that we need to exploit that data and create value from it. So finally, the things that will create the change, we need to break the link between sensors and devices and the applications so we can enable these new use cases. We can provide a number of integration points, make it cheap and easy to consume through as pay-per-use or cloud-type services. So it facilitates different integration of different data streams across a wide range of multi-sector use cases, so bringing together data from health, from energy, smart homes, vehicles, you name it. Standards is an issue that we've already spoken about. Our experiences today, we can't really be too concerned about standards. There's too many. It's too big a problem for anyone to deal with today. It will be resolved in time, but we need to think about how we gain value today and in the near future without getting bogged down in standards. And finally, the point of all of this is to enable us to create new value, new use cases from this capability that we've created through the cheap and ubiquitous sensors, the cheap and cost-effective networking, and the easy to use and easy to consume resources